Hi, welcome to today's webinar. Thank you for joining us. I'm Alan from AppViewX, and joining me is our host Murli, who's also our Chief Solutions Officer. For those who aren't sure what we do, AppViewX is a leading provider of certificate management and network automation solutions, and we are based out of Seattle. So in today's webinar, we're going to talk about the deprecation of TLS 1.1 and 1.0. Since they're obsolete now, there are several risks and implications of using them, and to stay secure, you'll want to know how you can migrate to the newest versions, 1.2 or 1.3. We'll talk about that and how you can go about it, how your PKI needs to adapt to accommodate these changes, and a lot more. Before we start off, some housekeeping items. If you have questions during the webinar, please type them into the Zoom control panel. We'll bring them up at the end of the PPT and we'll answer them. The webinar is scheduled for about 30 minutes of presentation content, followed by 10 to 15 minutes of Q&A, during which you can ask your questions. Also, this webinar is going to be available on demand after this live webinar is over, so if you miss anything, you can pick it up there. I think we can start. Murli, over to you.
Thanks, Alan. Good morning, good afternoon, or good evening, everybody, depending on which time zone you are in. Today, we are going to talk about TLS and how we can move away from TLS 1.0 and 1.1. As you would have known, right, the browser forum, the big four browsers decided to deprecate support for TLS 1.0 or 1.1, which means that next year, early next year, if you continue to use TLS 1.0 and 1.1, it will throw an insecure error in the browser, right? The reason is because of a couple of challenges and vulnerabilities that are there in leveraging the TLS, older TLS protocol. The recommended protocols are TLS 1.2 and 1.3 maybe, right? So we'll look at we'll look at a couple of things. We'll look at the history. We'll look at how to do it, what are the best practices, and all that. Before that, let's do a quick overview of what AppViewX does and what AppViewX is. So our AppViewX is a platform. It's a low-code application automation platform where we automate and orchestrate network and security infrastructure. And our primary focus is two areas where it's CERT+, which is a certificate lifecycle management product. This is primarily automating or managing the data in transit encryption piece of it, all the aspects related to data in transit. And then the Automation Plus product, which is all part of the same platform, is about network orchestration and automation of all the network services and security services. So our primary customers are large Fortune 500. We have some small, medium customers as well. Our primary focus is more on the regulated and automated areas, right? There is a lot more benefit in automating it and compliance, audit, and those areas. So we are a global company spread across the globe. So today we will talk about a little bit history of TLS. We'll touch upon various, how it started and all that. And then what are the challenges in deprecating these versions, these older protocol versions, right? And we will also look at what are the challenges and suggestions and recommendations from an upgrade or even just an update to the new protocol as to how you can switch to the new protocols and what you need to do. We'll also look at how AppViewX will assist in deprecating these these older versions of the protocol across all the endpoints and stuff as well. We'll assign some time for questions, Q&A, there is a Q&A panel. Either you can post your questions on the Q&A panel or the chat panel, and then we'll answer those. Right. So let me switch. Now TLS, this transport layer security, which primarily came in as a replacement for secure socket layer. Now, most of you would know that secure socket layer was found by Netscape. Netscape initiated that. It was an interesting company. They had patented the secure socket layer, which sort of brought in the name change in a way, even though it's not really. It's actually a next version of SSL v3, which is a secure socket layer which was there, which was widely used. SSL v2 and v3 were widely used initially. TLS was the next generation of it, which was primarily done to get out of all the any legal challenges that might arise. Even though Netscape patented it, they allowed it to be used by others. The key aspect is TLS 1.0 was not interoperable with SSL v3, which means you cannot switch over to SSL v3. And then TLS 1.1 was released in 2006. It had some upgrades or updates with and some protection. So we don't have to go into the protocol level details of it. We can talk a lot in those as to what functionalities are there from there. And then TLS 1.2, which is where majority of our internet traffic is right now, is widely used. And then TLS 1.3 reduces the round trip time, and then reduces. I mean, it greatly improves performance. And if you were looking at switching over, right, it makes sense to take a leap into TLS 1.3 as the core protocol support, as our primary support. But it requires, the biggest challenge in doing that is which endpoints are consuming your services, right? If it is a public-facing website or a web services layer, then we need to worry about what devices are consuming it. So in my previous life, when we had services, e-commerce services over the internet, we had browsers from Windows 3 and Windows XP using us still, right? I mean, right now, Windows XP is still out there, and there are companies who are paying a premium to extend the support, millions of dollars to extend support for Windows XP. It's interesting to hear, but it's still there. It's still out there. So if you're looking at migrating, or rather moving dedicatedly to TLS 1.3, those are some of the things that you need to look at. But if it's more for internal mutual authentication, which you can control, like you control both the endpoints, it makes it easier to start adapting TLS 1.3. So in 2020, 1.0, 1.1 will be deprecated by major browsers, which means that it is not going to be shown as a secure website if they only support TLS 1.0 or 1.1. And it's a good practice not to use those for your internal communication to secure your data in transit. So what are the immediate effects of this deprecation? One of the biggest aspects is PCI. If you are looking at compliance, you have to look at deprecating these protocols and how easily you can do it or seamlessly you can do it. Redirect to a honeypots page where they have to upgrade their browsers or upgrade their endpoints to support that is something that you have to look at. And that's one of the key aspects here. Now, when you prepare for updating to 1.2 and 1.3, right? So first thing is we need to identify which application, right, the endpoints access. Sorry about that. I guess there was some blip in audio. I hope you can hear me now. So the first aspect that you need to focus on is to make sure the endpoints, right, can support TLS 1.2 and 3, which means that if this is for securing data in transit, depending on what endpoints are involved, like if it's a browser to server communication, or if it's a server-to-server communication, like a mutual authenticated communication, or it's an internal communication for APIs and web services. The first thing is to make sure those endpoints support the clients, right? Supports TLS 1.2 or higher, right? The next important aspect is to make sure that the endpoints are configured to configure properly and securely to make sure it only supports these protocols. And then the other important aspect, if you are looking at TLS 1.3, is to make sure you use only SHA-2 certificates. And you have to sort of replace those certificates to support SHA-2. And then you basically, if there are older web servers or older services which doesn't support the new protocol, right? If it is Java-based, you might have to upgrade the base Java. I mean, there are some compatibility modes there to support the new ciphers. And if it's an older processor or older servers, you might have to look at both software and hardware upgrades that are needed as well for the upgrade. So what does TLS 1.3 bring compared to some of the previous predecessors? Right? So TLS 1.3 is actually a recent addition, and if you look at the average age of SSL versus where we are, TLS 1.2, I mean, it's been a decade old. Right? TLS 1.1 has been a decade old, and TLS 1.2 has been recently released. If you look at the length of time of internet history, it's even though a year is not too long, but the whole life cycle of SSL to TLS has been, over 2 decades. So it's not that huge of a time. But that said, some of the important aspects are reducing round trip time. So in one of the analysis, right, the TLS handshakes, primarily the whole approach of TLS handshakes is to make sure that the session keys are exchanged, right, securely exchanged. Now this sort of adds a 5 millisecond latency based on the analysis that was done. Because for that, the handshake that initially happens to establish the secure session. Now, TLS 1.3 reduces that considerably. It's a huge aspect. And removal of SHA-1 and some of the vulnerable ciphers is another aspect that needs to be looked at. So even though we spoke about SHA-1 deprecation some time back, you could still internally you could be using SHA-1 certificates and all that. So as you plan to move to TLS 1.3, you need to look at that and address those. And some of the vulnerabilities with RC4 ciphers and some of the beast exploits has been addressed as well. and then perfect forward secrecy. This is to prevent any man-in-the-middle type of scenario. So that's another important use case that you can look at. And then provisions for SNI, server name identification, and all that is another important aspect as well. So what are the challenges in migrating or in updating or switching to TLS 1.2 to 3, right? Technically, in any organization, if you look at data in transit, it is secured through TLS. So in essence, if this is like a financial or a healthcare or any regulated environment, you would have hundreds of or even thousands of endpoints communicating for a single application. Now, when you update to the new version, each of those endpoints should be able to, both the client and the server side should be able to support these new ciphers, support these new protocols, and update it. And if it is, it has to have those libraries supported as well to switch to these. I mean, it's not easy to identify the impacts, especially when there are hundreds of applications where there could be some legacy applications as well. But at the same time, from a security aspect, we have to look at how we can switch over and plan for those updates and upgrades. First, identify those areas, and then plan for the upgrades of the systems, right? So manually doing that, it's not possible. Meaning with hundreds of endpoints or thousands of endpoints for one single application, and if an organization has thousands of applications, it is not an easy task to do, right? It's quite time consuming. So you definitely need an automation tool, and especially when you look at an automation tool, how can you be safe that once you update, things are going to work? Right? It's never possible to say when you make a change, it's going to work 100%, right? So you need to first validate that the server side supports it and the client side supports it, and then plan on switching. And you definitely need a rollback capability. So those are some of the challenges that you need to focus on, that you need to look at. So when you look at recommendations, what we suggest is, first is you need to look at how you can configure each of those end systems to disable SSL and also TLS versions that are deprecated, right? And then you need to identify which one of those protocols are being run on those endpoints to first deprecate them or to configure them accordingly. And then look at all the data flows which are supported today, right, which you want to deprecate, and identify the endpoints which are communicating to each other. So you essentially need a map of every communication that is happening from the client to server, identify all those endpoints, and then mitigate them, right? And then identify if the servers will support it, right? What version of the servers that they are running, will they support these new ciphers? If not, how do you plan to upgrade them? What are the challenges there? Maybe highlight that as a risk or an exception and all that. So you'll have to look at that, and then discover every endpoint which has which runs which can support 1.2 and above as well, right? And then we need to verify or validate after you enable that it is only supporting that particular version, right? And it's not. Once you enable, you want to validate it. You want to confirm that it is only supporting those protocols. So you need to have a periodic validation just to be absolutely sure that it's not supporting any lower ciphers, lower protocols as well. And then block all the ciphers that are supported, that are not secure on the endpoints as well. And then another important thing is you should have a capability to roll back within few seconds if there is a business impact, so that you can go back to the last known good state type of scenario, either on a phased approach or a one-button rollback across the board for that application. So these are some of the things that you need to look at or focus on while you're switching over and migrating. So from a PKI perspective, what do we need to do to support it? First thing is you need to scan the entire network and identify the clients and servers which support those protocols, those vulnerable protocols, or potentially deprecated protocols, both SSL and TLS. And then identify the ones which are using a SHA-1 algorithm, so that needs to be updated with the new certificates to support TLS 1.0 and higher. Renew the certificates, replace them with SHA-2, and push the endpoints, push the certificates to the endpoints and configure them to start using that, and then configure them to stop supporting those older deprecated protocols. So what AppViewX does and how AppViewX helps in this is AppViewX supports a whole bunch of consumption type side tools. So you can use it using the GUI, so you can trigger this whole mitigation using the GUI, or you can use all the other CI/CD pipelines and other DevOps tools. And we have a growing list of integrations on the southbound side where we support all these device types from configuring and automating the flows for each one of those. So what AppViewX does is it basically scans the environment and it discovers all the vulnerable devices. So basically you can then group them into criteria. The criteria can be based on application, it can be based on device type, it can be based on a cost center, it can be based on a whole bunch of other things. You can group those devices, and you can define an automation workflow for bulk mitigation of those endpoints and bulk mitigation of the certificates that are affected as well. And then it can automate the configuration of the endpoint. When we say installation, it's a configuration of or deprecation configuration on that endpoint. And if you want to automate upgrade of those end services to support TLS 1.0 and higher, that is possible as well as part of the product. And then you can update the certificate infrastructure. You can also define a post-validation scan of the environment to make sure whatever we have set up is working as expected. So we have a discovery engine which will discover and tell you which versions are running and if they are clean and green as well. It will go look at all the certificates. It will go look at all the endpoints and then provide that capability. It gives you an end-to-end view of the endpoint and its certificates, and basically a holistic view. It gives you, for a certificate or for a service, what are all the services it's running, and you can basically right-click mitigate and right-click rollback for that particular service, for that particular certificate, if you're looking at it from a service perspective or a service URL perspective. So the process automation, this is a screen grab from a product where you can define how you can automate the process. So you can actually, there's a citizen workflow creation capability, a low-code capability where you can drag, drop, and define these approaches. And the workflow for auto-disabling or deprecating the configurations on the endpoints is first it will basically identify all the endpoints. It'll do a version check. It'll disable, 1.0 and 1.1 on that. After implementation, it'll do another endpoint check to make sure it is set up correctly and validated and all that, and it'll give you a nice graph on how it looks as well. So if you want additional steps where you want to create a change ticket, like a ServiceNow remedy, service desk ticket before it makes changes on that group of device, it can be defined. So there's a sample flow as to what is available, so you can basically update it, customize it based on your internal business process. It can implement on Java devices, it can implement on WebSphere, WebLogic, whatever, right? You can group all the Apache devices and mitigate them first, and then move on to other ones. Or if you have different teams, they can define their schedule to mitigate those as well. What is the value that we provide as part of that? One of the key aspects is you're able to move faster. You can mitigate this across your organization, enforce compliance, to make sure you validate and support in a secure environment, reduce the risk, and you eliminate errors by doing. If you had to do this manually, across hundreds of thousands of endpoints, it's going to definitely create unnecessary configuration errors. So we're going to reduce that. We're going to optimize costs because we're completely removing the complexity of doing this manually, and it's going to give you a huge saving. With that, I'll pause and I'll check for any questions that you might have, and I'll answer those. Okay, so there is a question there. What would customers or users of my service have to do prior to deprecation? Oh, okay. So what do they have to do prior to initiating deprecation? So one of the key aspects is the pre-checks or pre-configurations that you need to do. That there are workflows that we provide to check if the protocol support is there. But if you were to plan for it, right, first you need to get an inventory of all the endpoints that you have, right, and the support that it provides, whether those TLS later versions needs to be manually enabled or updated to support those, or it is by default enabled. There are certain endpoints, certain clients, and certain server side where you need to manually enable to support TLS 1.3 or higher. In some cases, you might even have to update the libraries to support those. So let's look at that, plan for it in an enterprise-wide. If you want to automate that, we have capabilities to do that as well. RSA or ECC for TLS 1.3? That's a very good question. So ECC, we should look at moving to ECC because of the advantages of the lightweight, the smaller keys and giving a better encryption and all that. Now it depends on who the client is, who's consuming your services. I would say take a critical look at switching over to ECC as a best practice if it is possible. So internally org-wide, you can always switch to ECC because you have control of client and server side. But in cases where you don't have a full control of your client, then I think it is safe to go with RSA just to make sure there are no compatibility issues and all that. Okay. Any other questions? Okay, that's good. All right, thank you, everyone. We will talk further. If you have any questions, send an email to info@appviex.com. You can always sign up for a live demo, or you can sign up for an enterprise trial. In that, do mention that you're looking for TLS deprecation so that they can give you relevant information to these focus areas, right? If you want a generic demo of the product, feel free to sign up for it. And if you want more information, you can go to our website and use the live chat to get more information about the product and about the capabilities. Thank you, everybody. We'll meet up in the next webinar.